Hello students, welcome to Ant's classes. Let's do special types of quadrilaterals, exercise 17. We are with question 7. ABCD is a rhombus. So we have a rhombus here. A rhombus is a quadrilateral in which all sides are of equal length. So ABCD, this is a rhombus given to us if angle BAC is 38 degrees. Now where is BAC? BAC. So this is BAC. So BAC, this is 38 degrees. This is given to us already. So let's write that here. So this is 38 degrees. Now we have to find a few angles. That the first one is angle ACB. Angle ACB. That means we need to find this angle. So first let's write what's given to us. We are given that ABCD is a rhombus. ABCD is a rhombus. So this is given to us. Then we are also given that angle BAC is 38 degrees. Now here, if you look carefully, now this AB and BC will be equal. These two sides will be equal. Why are they equal? Because they are sides of a rhombus and all sides of a rhombus are equal. So let's write that first. So we can say that AB is equal to BC, and what is the reason? Sides of a rhombus are equal. That means this side and this side are equal. Now, if the sides are equal, then we know that the angles opposite equal sides are also equal. And what are the two angles? The two base angles are BAC and BCA. These are the two angles that are also equal. So we can write that down. So let's write angle BAC is equal to angle ACB, and they will both be equal to 38 degrees, and the reason is angles opposite equal sides are equal. So we have found the answer to the first question, that is we had to find the value of angle ACB, and we have found it to be 38 degrees. So this is our first answer. Now we're going to go to the second part of the question, that is find angle DAC. So now to find angle DAC, now where is DAC? D, A and C. So we can write this, we can mark this as A. This part is A. So the angle in green is what we need to find out, angle DAC. Now let's consider AD and BC to be two parallel lines. So AD is parallel to BC. So in that case, we can take AC to be a transversal. AC will be the transversal. So what we are trying to show here is these are two parallel lines cut by a transversal. That means we can apply the property of transversals. That means this angle here, 38 degrees, and this angle, they will be alternate angles, isn't it? So applying the property of parallel lines, they will be alternate angles. So in that case, this will also be 38 degrees. So let's write that angle DAC will be equal to angle ACD, and both will be equal to 38 degrees. And what is the reason? Alternate angles are equal. Because alternate angles are equal, these are equal. So we have found the value of angle DAC. Angle DAC is 38 degrees. This is the answer to the second question. Now the third question is angle ADC. We have to find the third one, and that is angle ADC. So we have to find angle ADC, and which one is that here? Angle ADC. So this angle here. So the angle that is marked here, this is the angle that we need to find out. Now there are two ways that we can find out. One is if we can find this angle, then we can say opposite angles of a rhombus are equal. So this angle and that angle will be equal. Or if we can find this angle here, then when we add up these three, it will become angles of a triangle equal to 180. So we can find out that. So we can find in two ways. Now here, when you take this angle and this angle here, 38 and this angle, they are alternate angles. When you take these as the parallel lines and this cut by a transversal, this and this will become alternate angles. So here AD and BC are parallel lines. So it is like this. So here if we have AD, suppose I write this as A and D, and this is C and B, and we have this transversal moving like this, then these two angles will be alternate angles. These two angles that we see here will be alternate angles. So that is, here I have this angle here, that is here, this one 38. That means the alternate angle is coming there. That also will be 38. That is the two angles marked in yellow. So this is 38, that is also 38. So let's write it there. So this is also 38. And what is the reason again? Alternate angles are equal. So again, we can use that same property. Now we can find out angle ADC. Now how can we find out that? In triangle ADC, we can take it like that. In triangle ADC. Okay, we're talking about the triangle ADC here. In that, we can take all three angles, that is angle ADC plus angle DCA plus angle CAD. Okay, these three angles will be equal to 180 degrees. How is that? Angles of a triangle is equal to 180 degrees. So here we need to find angle ADC. We don't know, isn't it? Plus angle DCA is 38 degrees. CAD is 38 degrees. Together they will all add up to 180 degrees. So now we can find angle ADC. This plus 38 plus 38 is 76 degrees is equal to 180 degrees. Now to find angle ADC, we just have to say 180 degrees minus 76 degrees, and that is equal to 104 degrees. So we have found the value of angle ADC also, and that is 104 degrees. So this is our answer to this question. Question 8. ABCD is a rhombus. If angle BC is 35 degrees, find angle ADC. So what is given to us? ABCD is a rhombus. Let's draw a rhombus. Let's name it ABCD. So here we have A, B, C and D. So this is a rhombus. What else is given to us? This is also given to us. That is angle BCA. Angle BCA is 35 degrees. Now look at this rhombus. Angle BCA. That means there should be a diagonal here. Only then we'll get angle BCA, isn't it? So let's draw the diagonal. So we have angle BCA and this is 35 degrees. So let's mark that. So this side is 35 degrees. Now we need to find angle ADC. So much is given to us. We need to find angle ADC. So how are we going to find angle ADC? Now where is that? Angle ADC is the angle that is here. Angle ADC is here and this is what we need to find out. Now this is on a different triangle, isn't it? And we don't know any of these angles, so we need to find this out. So now we can take lines AD and BC to be parallel lines. So parallel lines means if you just extend that, you'll get an idea about parallel lines. Okay, so these are parallel lines. So you can just extend it. So you get parallel lines. In that case, this diagonal will be a transversal. So if you have two parallel lines like this, suppose I have two parallel lines like this, I'm talking about AD and BC. Suppose I have those two parallel lines and they are cut by a transversal like this. Okay, so we have two parallel lines, they are cut by a transversal like this. So AD is this line, BC is this line, and this transversal is this diagonal here. But we are given this angle here, isn't it? That means inside we are given one angle, and that is 35 degrees. So this angle and this angle, when two parallel lines are cut by a transversal, these two angles now become the interior alternate angles. And what do we know about interior alternate angles? They are equal. So if this is 35, this is also 35. So here 35 degrees, that means this one will be the interior alternate angle. This will also be 35 degrees. So how do we write that? We write that angle line AD is parallel to line BC. So because of that, angle BCA, angle BCA will be equal to angle DAC, and both will be equal to 35 degrees. And what is the reason? Interior alternate angles are equal. That is the reason, because interior alternate angles are equal. So this is also 35 degrees. Now to help us find the remaining angles here, we have to use this property also. Now look at the sides DA and DC. They are equal because all sides of a rhombus are equal. So these two sides are equal. So let's write that DA is equal to DC. And what is the reason? Sides of a rhombus are equal. And when sides are equal, the opposite angles also will be equal. That means the base angle. So this angle and this angle are the base angles. So the base angles also will be equal. So how do we write that? We write it as DAC will be equal to DCA, and both are equal to 35 degrees. And what is the reason? The reason is angles opposite equal sides are equal. So let's mark this also now. Now this is also 35 degrees. Now we can find angle ADC, this green angle, that is what we've been asked to find. Now we can find this angle because we know two angles, and to find the third angle we can use the property sum of angles of a triangle equals 180 degrees. So let's write that. So that will be angle ADC plus angle DAC plus angle DCA will be equal to 180 degrees, and the reason is angles of a triangle is equal to 180 degrees. Now angle ADC is what we need to find out, plus DAC is 35 degrees, DCA is 35 degrees, and all this will add up to 180 degrees. Now angle ADC plus 35 plus 35 is 70 degrees is equal to 180 degrees. Now ADC is equal to 180 degrees minus 70 degrees. So now we have found the value of angle ADC, and that is equal to 110 degrees. So this is our answer. Question 9. PQRS is a parallelogram. We have it here whose diagonals intersect at M. So we have one diagonal here SQ, another diagonal RP, and they intersect at M. If angle PMS, now PMS is 54 degrees, so let's write that. So this is 54 degrees, and angle QSR, now QSR, this side is 25 degrees, and SQR, we have SQR, this side is 30 degrees. So this is what is given to us. Now we have to find the first one, angle RPS. So what is given to us? PQRS is a parallelogram given to us. Angle PMS is 54 degrees is given to us. Then we have angle QSR is 25 degrees, and then we also have angle SQR is 30 degrees. So much is given to us. Now we have to find the first one, that is angle RPS. Now where is that? Now here we have angle RPS. That means this is the angle that we need to find out. Okay, to find out this angle, let's use other ways of finding it out. So first thing we're going to do is we're going to take PQ and SR as two parallel lines. Let's write that. So PQ is parallel to SR, and we're going to consider SQ to be the transversal. Okay, so in that case, SQ is the transversal, So we have two parallel lines and we have a transversal. So let's apply the properties of parallel lines being cut by a transversal. So in that case, this angle and this angle will be interior alternate angles. Okay, let me draw that and show to you. Now suppose you have SR here and you have PQ here. Okay, you have two parallel lines, and if you have a line, so if we have two parallel lines and a transverse, and this angle, which is 30 degrees, and this angle will be alternate angles, isn't it? and they are equal. That's why they are both 30 degrees each. So in that case, if this is 30, the alternate angle is this side of this angle S, and that will be 30 degrees. That is, these two angles in green will be 30 degrees. So let's write that out. That is, angle PSQ is equal to angle RQS, and both are equal to 30 degrees. So this will also now be 30 degrees. And what is the reason that they both are equal? The reason is interior alternate angles are equal. So now that we have found this and this, we can find this angle, isn't it? Because we've been asked to find angle RPS. We just need this angle. Now we can consider this triangle SPM. So in triangle in triangle SPM. Now here there are three angles, isn't it? 1, 2, and 3. To find the third angle, we have to just add up these two and subtract it from 180, because we know that the sum of angles of a triangle equals 180 degrees. So we are going to find angle RPS. So let's write that down. So in angle SPM, angle RPS plus angle, that will be angle MPS. RPS is what we're going to find out. So angle MPS, because we're taking only this triangle. Angle MPS plus angle PSM. PSM plus angle SMP. That is, we are talking about this triangle with these three angles, and they should add up to 180 degrees. Why is that so? Because angles of a triangle equals 180 degrees. So now we're going to simplify this. Angle MPS we don't know. This is what we're going to find out, plus angle PSM. Where is PSM? PSM. So that is 30 degrees. So let's write that here, plus 30 degrees. 30 degrees plus SMP. Where is that? SMP. That is 54 degrees. Let's write that. Plus 54 degrees. All this will be equal to 180 degrees. So now to find angle MPS, plus how much is this? 54 plus 30 is 84 degrees. This is equal to 180 degrees. So angle MPS will be equal to 180 degrees minus 84 degrees, and that is equal to 96 degrees. That means we have found this angle to be 96 degrees. So let's write that. So this is 96 degrees. And what is our question? Question is this, that is, we have to find angle RPS. Now let's see where it is. So we have R, P and S here, and angle RPS is 90 degrees. So we have found the answer to this. Angle RPS is 90 degrees. Now, our second question here is we have to find angle PRS. Now, which one is that? Angle PRS. We have to find this angle. So let's color that in blue. Okay, so this is the angle that we need to find out. Now here, as you can see, we already know S here, isn't it? This whole thing is S. We know P, and now we just have to know R. So let's take this triangle PRS, the whole triangle PRS. So in triangle PRS, if you take the triangle PRS, the angles, that is SPR, angle SPR plus angle PSR plus angle PRS. All this will add up to 180 degrees. What is the reason? Angles of a triangle equals 180 degrees. Now how much is angle SPR? Angle SPR is 96 degrees plus angle PSR. PSR is this angle here. This is S. So when you add up these two, you get PSR. So 30 plus 25 is 55. So that is 55 degrees plus PRS, which is the angle that we have to find out, is 180 degrees. So to find out the angle PRS, we add up these two. So how much do we get when we add up these two? we get 151. That is 151 plus angle PRS is equal to 180 degrees. So now to find only angle PRS, what do we say? We say 180 degrees minus 151. So we have found angle PRS, and that is 29 degrees. So this is question 2. We have found angle PRS, that is 29 degrees. So this we have found. Now the third question here is we have to find angle PSR. Now where is PSR? PSR is this thing, and we have already found it here, isn't it? So all we have to do is add it up. So angle PSR is equal to 30 degrees plus 25 degrees, and that is equal to 55 degrees. So we have found the third angle also, and this is 55 degrees. Question 10. Parallelogram ABCD in which diagonals AC and BD intersect at M. This is given to us. So this is the parallelogram ABCD. We have diagonals AC and BD and they intersect at the point M. Now what should we prove? We must prove that M is the midpoint of Ln. So we have Ln here. We have to prove that M is the midpoint. If M is the midpoint, then this part Lm will be equal to Mn. So this part will be equal to this part. So that is what we have to prove with the help of all what is given to us. So to prove this, what we actually have to prove is that Lm is equal to Mn. So if these two are equal, then M will be the midpoint of the line Ln. Now the first thing we'll take is BM and MD. Now this line BD. Okay, now since it is a diagonal, the diagonal has bisected the parallelogram. So BM will be equal to MD. So let's write that first. So BM is equal to MD. And what is the reason? How do we know that these are equal? Because diagonals of a parallelogram bisect each other. So that's how we know that BM is equal to MD. The next thing we're going to do is we're going to take this triangle, that is triangle DLM, and this triangle NMB. So these two triangles we're going to take and we're going to prove their congruency. Congruency is a chapter that you've learned last year, isn't it? We have to prove that these two triangles are congruent. That means if they are congruent, their corresponding paths will be equal. So let's take the two triangles. So one triangle is triangle DML. Okay, so triangle DML is equal to, and now if we take triangle DML and triangle BMN, I hope you've understood which these two triangles are. First one DML, it's this triangle, and then BMN, it is this triangle. So we're talking about these two triangles now. Now look at these two triangles. Now if you see here DML, let me mark that, that is DML is here, this side. And if you see the other one that is here, that is BMN, the angle that is here, that is the angles marked in red, they will be equal. Why? Because they are vertically opposite angles. So let's write that. That is angle DML. So I'm talking about angle DML will be equal to angle BMN. Why? Because they are vertically opposite angles. Now the next thing, let's consider AD and BC as two parallel lines. Okay, so let's write that down. So AD and BC are parallel to each other. Then if you can take this as the transversal, if you take this as the transversal to these two parallel lines, then this angle, that is here, angle ADB, this angle will be equal to this angle. Okay, if you consider these as two parallel lines and this as the transversal, this and this, that is, both these angles in green will be equal. Why? They will be interior alternate angles, and interior alternate angles are equal. So let's write that down. Angle ADB, so let's write that angle ADB will be equal to angle DAC. Okay, so did you get that? Angle ADB, this is in green, and angle DBC, angle DBC, that is here again in green, they will be equal to each other. And what is the reason? Interior alternate angles are equal. So that is the reason for that. So now we have two angles here that are equal, and these two angles are equal. Now this side and this side, we said in the beginning itself that they are equal. Okay, so now you can use one of the rules of congruency. Here we have angle, side, angle. Here also angle, side, angle. So these two angles, we have triangles, we have proved to be congruent to each other. That is, let's write it down. Triangle DML, triangle DML is congruent to triangle BMN, triangle BMN. And then we also know that in congruent triangles, the corresponding parts will be equal. That means this is equal to this. These will be the corresponding parts. So LM will be equal to MN. So let's write that. So that will be LM will be equal to MN. And what is the reason? The corresponding parts of congruent triangles are equal. So we have to remember that we are following the rule angle, side, angle for this first part here, angle, side, angle. And now we are saying that these two also are equal to each other. And what is the reason? Corresponding parts of congruent triangles are equal. Simplicity we say because corresponding parts of congruent triangles are equal. So in that case, if both these sides LM is equal to MN, it is proved that M is the midpoint because this has divided this line into two equal parts. So we can write that. We can say now the corresponding parts of congruent triangles are equal. So this has proved that LM is equal to MN. That means M is the midpoint of LN. We have proved that M is the midpoint of LN. So we have proved. So you end by saying hence proved. So I hope you will follow all these parts carefully and then work this out and then get your answer correctly. So we will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.